So the next example, we have a lot of pieces to go through. I'll probably end up making some sign charts on this page, and I can also use some shapes of the U. There's a lot of ways to approach it, but I like sign charts when I feel overwhelmed, and I'm already looking at this feeling overwhelmed. This is continuous and differentiable everywhere except for x is -2 and +3. So at -2 and +3, I have 3 choices. I can make it discontinuous. I can do a cusp or a sharp corner, or I can do that vertical tangent if I'm feeling ready to try to draw something like that. The first piece of this, just going for some partial credit, would be to put the point 1/2, 2 on the graph. So I'm going to go ahead and do that just so I don't forget it. 1/2, 2. That looks about x is 1/2, y is 2. There's a point that I'm definitely going to go through. The next piece tells me where it's increasing and where it's decreasing. Let's just go ahead and make that right into a sign chart because that is too much. If the x value is listed here, if it's part of the answer with the infinities, it must be a critical number. Only critical numbers and infinities go in our intervals for increasing and decreasing. So I notice I have 1/2, 3, and -2 in these intervals. So those are my 3 critical numbers. So I have -2, the next one would be 1/2, and the last one would be 3. 3 different critical numbers for this graph. Only critical numbers can go on these intervals, so they must be critical numbers. So now I can take each piece and actually put it on here. Let's look at our first piece. It's increasing from 1/2 to 3. Increasing from 1/2 to 3. And 3 to infinity. So what do I get at 3? If it goes from increasing to increasing, it's going to be neither a max or a min. My next piece, where it's decreasing, is -infinity to -2. And -2 to 1/2. So what do I have at -2? It goes from decreasing to decreasing. I get neither. But at 1/2, I switch from decreasing to increasing. I actually get a sign change. So what does that sign change look like? It looks like a relative min. So my point that I put on there at 1/2 should be a relative min when I think about it later. Okay? Let's make another sign chart. Try not to get overwhelmed. We're just going to take it piece by piece and hopefully it comes together. So this next one says the second derivative is positive, which means concave up on the interval from -2 to 3. So this means these must be my possible inflection points. -2 to 3. Hey, same numbers from above. And then concave down from -infinity to -2 and 3 to infinity. So those are my only 2 possible inflection points. Let's see if they are. See if concavity changes. So I'm concave up from -2 to 3. -2 to 3 is right in here. Is where I'm concave up. And let's make it match the sign chart above. The sign chart above says it has to be concave up and switch from decreasing to increasing. So let's figure out which concave up picture has that happen. Concavity is super powerful. This is when we're going to actually get a good idea of what the picture looks like. So concave up, and between 2 and 3, the first derivative goes from decreasing to increasing and is concave up. So this first piece is decreasing to increasing. This one's always decreasing. This one's always increasing. So which one is the one that looks like this picture? It's the one that's decreasing to increasing. So the first part of my graph that I know for sure is this piece here. It goes decreasing to increasing. Okay, trying to make these two sign charts look like they're graphing the same function, because they are. This is all the information about one function. I'm concave down from negative infinity to negative 2. And not only am I concave down, but the first derivative says I'm decreasing. So I'm going to draw my 3 u's and figure out which concave down is decreasing. So I have an upside down u, just the left side, and just the right side. Which one is concave down but also decreasing so that I match my first derivative sign chart? This one's increasing to decreasing, this one's always rising, this one's always falling. So it must be this picture. To match both pieces, has to be concave down and decreasing. So that's the shape it has to be. And then from 3 to infinity, it says we're still concave down. So I'm concave down again. I need to pick another concave down, but this time, after 3, I'm supposed to be increasing but concave down. So let's look at our pictures, and you can draw all 3 again if you want to. I'm going to draw all 3 just for practice. Left side, right side, and the full U. The one that's always increasing is just this side. So this concave down and increasing must look like this. Okay, now I have a really good idea of what the graph looks like. It looks pretty weird, but that's a fair answer. This is decreasing but concave down. That looks good. This is decreasing then increasing while always concave up. That's good. And this one's rising, but it's concave down. That's good. Sign charts should be drawing the same thing. They're for the same function. So the next piece I have to draw in there is a horizontal asymptote at y equals 0. I'm going to switch colors so it's easier to see on the graph. So at y equals 0, a horizontal asymptote is the limit as you go to infinity. So as you go into infinity or to negative infinity, far out to left or to the right, we're going to stop at 0. Remember, horizontal asymptotes are limits at infinity. As you go to left, to the right, what y value do you stop at? For this instance, it's y equals 0. So I'm going to do some dotted lines to put that asymptote in. And then I have a vertical asymptote at negative 2. So I'm going to draw some vertical dotted lines. Vertical asymptote at negative 2. And at x is 3. Hey, that's pretty perfect because, yeah, wasn't I supposed to be? I was supposed to be discontinuous or not differentiable at negative 2 and 3. And if I put some vertical asymptotes in there, then I'm discontinuous. So I'm not continuous and I'm not differentiable if I have that vertical asymptote as my discontinuity. So that looks good. And now I just need to draw a picture. And you remember there's more than one right answer. It doesn't have to be super perfect or anything. So I'm going to start with the middle piece. This U has to be decreasing, increasing, and it has to go through the point that I was given. I was given this point 1/2, 2. So I'm going to decrease and then increase and make it look continuous, except for at negative 2 and 3. Okay, the next piece I'll draw is maybe the left piece. I need to draw this shape where it's decreasing and concave down. I have 2 options of where I could draw it, so don't draw both. Just watch me draw and let's pick the right one. So this is decreasing and concave down, just making this shape here bigger. Or this is decreasing and concave down. Which one should I choose? Which one is approaching the horizontal asymptote and the vertical asymptote? Only the bottom one. I'm supposed to be approaching this y equals 0 line, and I'm not if I put it up here. So this can't be the right answer. It has to go down there so that I can approach my horizontal asymptote, my vertical asymptote, and be decreasing and concave down. Where it actually is exactly, looks like I go through the point 5, negative 1. That was by accident. You don't have to go through that exact point for yours to be correct. But it has to be decreasing and concave down and approach that horizontal asymptote at y equals 0. My last piece is drawing this concave down piece that's also increasing. I want to make sure I approach my horizontal asymptotes and my vertical asymptotes. So I have 2 options to choose from. Don't draw both. Just help me pick the right one. This is increasing but concave down. And this is increasing, but concave down. Which one's the right answer? Which one's approaching both asymptotes? The only one approaching our horizontal asymptote is the bottom one. So that's what I would draw there. My arrow kind of looks like it's going straight up, so I'm going to redraw that a little bit nicer. But I'm not too picky as long as you have the right idea. There is my answer. Kind of looks too straight now. I'm being super picky, but that's just because it's hard to draw on my tablet. So something like that, increasing, oriented downward, and approaching both of our asymptotes, the vertical asymptote and horizontal asymptote. So lastly, I would just suggest going through each piece and checking that you have it true. So am I not continuous or not differentiable at -2 and 3? Yeah, because I have my vertical asymptotes there. So I met those two pieces. It's not differentiable and it's not continuous there. It has my vertical asymptotes. My horizontal asymptote is being approached on the left and the right. And then I matched the two sign charts as well as going through point 1/2 too. So you can just kind of go back and double check. Does everything seem to match up?